Hello everyone, hope you all are doing well. So first of all, sorry as I am not able to upload yesterday video, but I hope you all are able to solve that problem by your own, as it is an easy level problem, and I will explain it in some other day. Okay, whenever it comes again, I will solve it and upload it. So let's do today question. Today question is Leetcode number 24, swap nodes in pairs. It is a medium level question and I also feel the same. So you are given a linked list and you need to swap two adjacent element. Okay, but you will not uh, you are asked to not modify the value of in the list node, and you only node themselves may be changed. Okay, means you cannot swap the value, you have to swap the complete node. Okay, so if you see here, it is 1 2 3 4. So 2 is swapped with 1 and 3 is swapped with 4. Okay, and if it is empty, then you have to return empty, and if there is only one node, then you have to return only means there is no element to swap for, so you need to return the original. Okay, and the constant are the number of node in the list is in the range is from 0 to 100. Okay, so there can be maximum 100 nodes, and all nodes value can go from 0 to 100. Okay, so let's go through the explanation. So for the first example, it is 1, then it is pointing to 2, then it is pointing to 3, then it is pointing to 4. Okay, so you can do it iteratively, but it will be a bit complex. So I have done it with recursion. Okay, so here's one thing you need to observe, that if there is only one element, then you need not to swap. Okay, so this is very important condition, and it will help us to understand the recursive code. Okay, so keep remember. Okay, so first of all, what I take the base case is like if there is only one node, means its next should be null. Okay, so I check if my current node is null or the current next is null, then I will do nothing. I'll just simply my current node, if it is null, then it will return null, and if it is one, means if it is a single node, then it will be return a single node. Okay, and as we are doing it in recursion, so what is the issue with the means that while loop? Okay, iterative method, like if I swap the first one and I swap it like this. Okay, but this one is then pointing to 3. Okay, and this is pointing to 4. So you need to keep track when you swap it, so it will be like something like look like it is the 3 is still pointing here. Okay, means the 1 is still pointing to 3, so it will not get changed. Just what you have done, when you try to swap it now, you just remove this 3 and just 1 is pointing to the 4. Okay, so this is the issue. So you need to keep a track of three things, this one and the two which you need to swap. Okay, but in recursion we did not need to do this all this stuff. Okay, uh, and you can try the iterative approach also, but I found the recursive one a bit easy, so I have done that one. Okay, so what we'll do from back to front. Okay, means I call for the recursive call first, then I will keep track of means I will update it. Okay, means I will swap it. Okay, so what I just initially call this one, then I will swap this with this two, then I will call its next to next element like this one. Okay, for I will call this one. Okay, then I I call it for next to next one. Okay, then I call here, it is nothing, so it is a null. Then I call it for here. Okay, this is the third recursive call. Then you can see here it is a null. Okay, so it will return a null. Then I came back to this recursive call. Okay, this 3 means my stack look like this is the first, when my current pointer is in the first, then this is the third, and then it will be the null. Okay, then after that it will return here a null, and it will remove this. Okay, it will, just a second. Okay, it will remove this one from the stack. Okay, so like this. Then I again it will as it return the null, I just swap it. Okay, then it will look like 4 and 3. How you can do whatever you like to swap. I will use a temporary variable to swap it. Okay, you just swap it, and its next element just simply put this one which I have which the recursive call return previously. Okay, for this example it is return null, so I'll put here null. Okay, then I will return my this node. Okay, this node, then this will processed and it will return me a 4 because I am returning the first node. Okay, then I will show you the code what of which variable I have written, but you can keep track of this. Okay, so as you are keep tracking of both this node to swap, so you can keep track of this, so it will return 4. Then again I call to my previous, that is 1 2. Then I swap this 1 2, so it will be 2, and then it will be 1. Okay, then as you have seen that it is returning the 4, so you just keep, what you will do, you just point out this 1 to of whatever the value I have returned. Okay, so I hope you understand. And if there is like not something like 1 2 and 3, if there is only one node, then I call it for this one, then I will ignore it and I will call for this one. Okay, but here you can see that its next element is null, so you cannot swap this element. So whatever, so what it will do, it will simply return 3 to our previous call. Okay, means this node to our simply to the previous call. Okay, then it will again perform the same thing. Okay, so let me show you the code to understand you a better way. Okay, so I have taken a current pointer and I just uh, pass it, okay, to the here, but you can also take the head pointer and pass it. It is not an issue. Okay, then I call I have function called as rec, and its return type is of course list node type. Okay, then I check if my current node or if my current next, if one of them is not available, then I will return my current. Okay, because in recursion we are breaking these elements into okay, separate parts. So whenever we encounter with a single node or a empty node, then I just return it simply. Okay, then it will return, and it will store in the t variable. Okay, whatever I return from here, okay, here or here, it will store it's in previous call at t. As I have shown you, it will return null here, then it will return 4 here for the first example. So this values get stored into this pointer t. Okay, then I just do a quick swapping here. Okay, I just store the current next, means in my previous, when I am returning the null. Okay, so my previously my current is this 3 now, so 3 next is 4, so I store this 4 in a this 4 in a temporary variable called temp. Okay, then I point this next to here, and I point this next to here. Okay, means the temp next will point to current, and this elements next will point to next. Okay, so I have done the same thing. First of all, I just simply change the pointer, and the 3 pointer will pointing to the x, means the null. Okay, so this is the step. Then I have pointed this temp pointer, means this 4 pointer to our 3. Okay, means current pointer. Okay, then I simply return this one. Okay, because after swapping this one will come here, so I have to return this this node. So I just return the temp. Okay, as it is the temp, this 4 is the temp, so I just return temp, and it will perform recursively. So after some time it will solve the whole code, and it will return our final head node. Okay, and I just simply return it to the driver. Okay, so let me submit the code. Okay, it is submitted. Earlier it has taken 0 millisecond, now it is taking 7 millisecond. Don't know why, but it will work fine, absolutely fine. So hope you enjoy the video and you understand the concept, and I hope you you get some clear knowledge of the recursion after doing this question. Okay, so see you tomorrow. Till then, goodbye.